Okay, we're going to do moments, we're going to do it nice and quick, we're going to go through just the bits that you need to know. This is revision, this isn't learning. You need to make sure you completed the quiz beforehand, you complete the after quiz at the end to make sure you've made some progress. If you're still not getting good marks, you need to go back and watch this video. I'd also recommend that you stop it and pause it when we do examples, so you can do them on paper as you're going through. Alright, let's look at this idea of moments. Well, if you really understand moments, you'll understand these two questions. Why does a wheelbarrow have long handles? And why is a crowbar so long? These are two important ones. To understand them, we need to know an equation for moments. So, a moment is not a force, it's a turning effect. And I don't like the term turning force. We don't use that because that suggests the wrong units. Turning force suggests the units of newtons. And that's not right. Well, what is the unit? Well, if it's a force times a perpendicular distance to the pivot, it's going to be newtons times by meters. It's going to be newton meters. Let's look at the symbols as well. So, moment is force times distance, and like I said in units, we've got newton meters because it's newtons times by meters. What does perpendicular distance mean? Well, you've got to take, let's imagine, look at this donkey, let's imagine his weight force acts about here going downwards. The perpendicular distance is, if you imagine a dotted line through that, a dotted line through your pivot, it's the line at right angles to those, it's the perpendicular distance. Okay? Now, very quickly, pivot, sometimes you see the word fulcrum, it means exactly the same thing. We've got to know this. So, let's apply it. Why does a moment, otherwise known as a turning effect or a torque, what happens when I've got longer handles? Well, it doesn't change. The moment is the turning effect needed to turn the thing. It's not going to change whether I have long or short handles. What will change though? Well, if you think of the equation, the bigger perpendicular distance, because it's now from here to here, that distance, as opposed to maybe if my handles were this long, it would only be that. Well, mention all three bits of the equation. Okay? Mention my moment, force, distance. Same moment, same wheelbarrow. Bigger distance, so I'm going to need a lower force. Mention all three bits. That means I can lift my wheelbarrow, turn it with less force. What about my crowbar? It's the same, isn't it? Same moment, same crowbar, bigger distance, therefore I need a smaller force. Okay? Mention all three bits. Let's look at some simple examples. For each one of these, we're going to use equation, working, answer, unit. We're going to use EWAL. So what's the equation? We've just done it, force times perpendicular distance. I've been a bit lazy there, not written the full thing. That's okay. My working for this one, well, that's my numbers. My distance is 0.4, my force is 4, so we've times them together. We're going to get 1.6 Newton meters, that's my unit. Now, we need to say whether it's clockwise or anti-clockwise. How do I work it out? Well, put your finger at the pivot point and think about what's this one going to do. It's going to turn me this way. So if you think of your clock face, that would be anti-clockwise. What about this one? That's the same, isn't it? It's going to be anti-clockwise. What about this one? Finger at the pivot point, it's going to be turning me like this. It's going to be turning me clockwise. So very quickly, 4 times 0.2, answer with unit, and whether it's clockwise or anti-clockwise. Working, answer, unit. For each of these, I should have written the equation at the start. Okay, if you're struggling with that, go back and do it again. Next, it's going to get harder. We know the principle of moments. Well, that's when I've got a balanced system, a system in equilibrium. It's one that's not turning faster or slower. Usually, it's a system that's stationary, like a seesaw. So we say it's the sum added together of the clockwise moments is the sum of the anti-clockwise moments. So if I add up all the anti-clockwise moments, that will equal to all the clockwise moments about any pivot. So let's look at an example. Well, for this one, I've got an anti-clockwise moment and a clockwise moment. This one is going to be 10 times 2, it's going to be 20 Newton meters. this is going to be 1 times something. Well, what would it be? Well, I know it's balanced, so I know the moment must be 20 Newton meters, which means the force, 1 times something is 20, it must be 20, mustn't it? Alright, let's do another one. Let's set it out a bit better than that, because it could be done a lot clearer. So imagine I was given this situation. Anti-clockwise, and I don't know what this is, so I'm asked to find this. Clockwise and clockwise, so I've got to add up these. Before you do anything else, write your principle of moments, you'll get a mark for it. Sum of clockwise equals sum of anti-clockwise moments. Make sure you write it down. If you don't, you will make a mistake. Well, the clockwise moments, I've got 2, so I'm going to add them up. And I'm going to apply 1.5 times W. If we then times it out, you get this, divide through by 1.5, and you get your answer. Every time, write the principle of moments and get your units right at the end. Here I'm finding a force, my unit will be newtons. One more. I've already written out my principle of moments. So listened, I'm going to do it every time. Clockwise moment, well, it's this one. What's this one doing? Well, put my finger here. Can you see it's going anti-clockwise? It's put in there to trick you. This one, again, anti-clockwise. So I bang my numbers in, do my maths, get my answer, plug it in. Make sure I've got my right unit at the end. Last one. We've looked at moment, we looked at the definition, we've looked at what happens if I'm balanced, we looked at the principle of moments. Now let's look at what happens if I want to turn something. Well, for turning something, I need to look at this truck. We're going to try and get this car out of the water, so I'm going to provide a clockwise moment on the car. This guy is going to provide an anti-clockwise moment. And can you see that there's my pivot point? You've got to be sharp to see that that's my pivot point. So I've kind of got one distance here, one distance here. That's okay, it looks balanced. No, it's not. Because the car's fallen into the water, that means it wasn't balanced. To describe this, let's go back. This moment, the clockwise one, must be smaller than the anti-clockwise one. If one's smaller than the other, we say we've got a resultant moment. And you can see that this resultant moment is going to be anti-clockwise, which is going to cause it to spin faster and faster until it hits the water. So we've got a resultant moment, it's no longer balanced. So I need a bigger truck. The bigger truck's going to rescue the little car, easy peasy. I've got a bigger moment this side because I've got more mass, bigger perpendicular distance to the pivot. Yeah, easy, easy, easy. Lift it up, hooray, we saved the day. We're still going to get the first guy out. We still got to get this guy out. Oh, we got a bigger mass, we got a bigger perpendicular distance. But it's alright, it's going to be alright. No, it's not alright. Falls in. And of course, we just have to leave them there. They just get wet, that's fine. Alright. We need to say the 3 things. We need to say anti-clockwise moment is bigger. We need to say that's a resultant moment so that it spins or spins faster. Alright, that's it. There's not much for moments. These are the key points. An equation with symbols, with a unit, principle of moments, and what happens if you spin faster. Go and do the quiz at the end. Go back and look at the video if you get anything wrong. Good luck.